Hi everyone, my name is Akhil Arora and I am a PhD student affiliated with the Data Science Lab at EPFL in Switzerland. Today I'm going to talk to you about how well and under what scenarios can we approximate Wikipedia reader navigation behavior using synthetic data generated from publicly available sources. This is joint work with Martin Gerlach from the Wikimedia Foundation, my colleagues from the Data Science Lab, and my advisor Bob Best. When users browse any website, they leave information-rich traces of their navigation behavior, which further tells us how these users interact with or consume the content provided by these websites. In the context of Wikipedia, these traces can be thought of as depicting the learning pathways taken by the Wikipedia readers. Naturally, insights into navigation patterns have high utility, as they can help us understand and better serve readers' needs. They can be used to address knowledge gaps, or they can be used to identify and mitigate any structural biases that may exist. Well, they can also be used to organize articles into a curriculum for Wikipedia readers, which will only help improve the reading experience for these readers on Wikipedia. That said, despite so many interesting and important applications, systematic studies on navigation in Wikipedia are fairly limited, and this is because of one key challenge. In a commitment to protect the privacy of Wikipedia readers, the real navigation traces are kept private by the Wikimedia Foundation. Thankfully, there exists a publicly available resource called the Wikipedia Clickstream, which is a data set that consists of counts of referred resource pairs extracted from the very privately held navigation trace data logged into the servers of the Wikimedia Foundation. One can think of these interactions as being the interactions that happen in the first hop neighborhood of each page. To also further ensure privacy, what is done is that all the interactions that happen less than 10 times are also omitted from this data. While this is good news that there exists a publicly available resource that captures navigation on Wikipedia, this data set presents one more challenge. The next page visits here only depends on the current page and not on any other previously visited pages. In other words, we can say that this data set only captures the first order reader navigation behavior. In the remainder of this talk, we will now assess the utility of the Wikipedia Clickstream as a resource for studying reader navigation on Wikipedia. And we do so by formalizing two key research questions. First, how different are real trajectories from synthetic trajectories generated using the Wikipedia Clickstream? And second, how well can we approximate reader navigation via Wikipedia Clickstream data? To answer our research questions, we look into 4 different types of synthetically generated trajectories and compare them with the real trajectories using 6 different analyses conducted across 8 different Wikipedia language versions for which the Clickstream data is available. Talking a bit about synthetically generated trajectories, we look into this table, which summarizes the main characteristics of all the data sets considered in the study. One can observe that one commonality across all the synthetically generated data sets is that they follow a Markov order 1 process. That is, they only capture first order reader navigation behavior. One key difference that emerges is that the transition probabilities that governs the random walks for generating these sequences are different because they are obtained via different resources. For further details about the data generations, we refer you to our paper. Moving on, we will only focus on one specific analysis that was conducted in the paper, only in the interest of time, and also because of its intuitive appeal, which is the mixing of flows. And for all other analysis done in the paper, we refer you to the fuller content in the paper. So in this analysis, what we do is we look into trajectories that pass through a given article, and we connect the source and the target pages. And what we want to do is we want to assess whether there exists any predictability. That is, given the knowledge of the source article, can we predict what's the likely target article that passes through the intermediate article. Let's look at an example, right? So in this particular plot on the left side, what we can see is that the intermediate article is Charles, Prince of Wales, and we are looking into all trajectories that pass through this article. And the sources are indicated on the left and the targets are indicated on the right. And both plots have the similar organization. What can be seen is that one can see a mixing that we can observe in the incoming traffic and the outgoing traffic. And our intuition is that the higher this mixing, the lower the predictability, which becomes clearer when you look at both the plots, because on the left side, it's unclear that even when we know the knowledge of the source, that is Elizabeth II, the targets appear almost equally likely. So we cannot predict with higher probability what's the usual target. On the other hand, on the right plot, what we can see is that it's most likely that we will take this path. So to formalize this further, what we say is that the predictability is how strong, the predictability is captured by how strong or weak the mixing is. That is, the stronger the mixing, the lower the predictability, and the higher the mixing, and the weaker the mixing, the higher the predictability. And this thing is formalized using mutual information. This basically captures how much does one random variable tells us about another. And in this case, basically how much does the knowledge of source actually tell us about the target article T. So thinking about the extreme case, what we can say is if there is no predictability, that is the knowledge of source and the random variables depicting the source and the target articles are completely independent, then the mutual information will be 0 and the mixing would be high, and vice versa. And this is exactly what happens here, right? This left side of the plot indicates strong mixing and we observe a very low mutual information. And the right side of the plot indicate weak mixing, high predictability, and that's why we observe a high mutual information. So this serves as the base of this analysis, but what we see next is actually a remarkable finding. What we see is that majority of real trajectories actually exhibit very strong mixing or mutual information close to 0. And only less than 10% pages have mutual information higher than 0.1. And this is a plot which depicts exponential decay. So this particular finding shows that most trajectories in the real navigation sequences observed in Wikipedia have almost no predictability, and that's why they are closer to an order 1 process. Well, the idea is not to overwhelm the reader with the numbers, but what we want to show here is that the key message is that the relative difference between real and synthetic navigation sequences is actually well within 10% for majority of the downstream tasks and the analysis conducted in this work. Moving on, the key takeaways and implications of this work is that for many cases, clickstream data is good enough for studying reader navigation on Wikipedia. And the most important impact of this finding is that research of navigation in Wikipedia becomes accessible to a wider audience. In fact, the WMF team has already started working on actually generating clickstream data for more and more languages. Then the other important aspect is that it actually bolsters user privacy because there is no need to store or reveal sensitive data for majority of the cases. That said, there exist cases when real data is required. That is, the clickstream data is not good enough. We can think of some examples like when we want to track activities of the same users, like revisitation patterns or multi-tap behavior, or when we want to understand more about how users interact with different content of a Wikipedia page, like images or info boxes, or even understanding information consumption patterns, which involve knowledge of timestamps or geolocations. And these things cannot be done using the Wikipedia Clickstream data as of now. Anyway, the most important aspect is that this study has a broader impact because for most practical downstream applications, the Clickstream data is good enough. And Clickstream-like data can empower broader research on user navigation on online platforms. Thereby, this is an encouraging call for the community to release such data sets wherever possible. There still exists an open question whether our findings will generalize beyond Wikipedia, but this is an interesting question in its own right and should be studied. So we would like to say that this work provides quantitative evidence of the utility of Wikipedia Clickstream as a public resource that can closely capture reader navigation on Wikipedia. And we encourage everyone to use Wikipedia Clickstream for their downstream tasks. For the code or the data sets that were used in the study, we encourage you to visit our GitHub page under the DHAP GitHub organization. For a preprint of this server, you can access the preprint on archive. And you can contact me by either sending me an email, connecting on Twitter, or if you want more information about my research, you can visit my website. Thank you for your attention. Ciao.